Hi everybody. Sorry I can't be there today, but I'm sick. I don't want to get anybody else sick, so I'll do my best to go over the answers to this step by step so you guys can see how all these are done. Remember, the final exam is all short answer. You will see a test that's very similar to this review. Approximately the same length, same style, where you've got about a page per unit. So we start off with the first problem here from Unit 1, where you're making a graph, linearizing it, writing an equation, and answering questions. So with final exams quickly approaching, you want to see how much time you need to spend studying in order to get the grade you want. You gather your previous 6 tests and remember back to how much time you studied for each. You're going to have one like this on your test where you have to linearize by hand. So make a graph of score versus minutes studying. The time studying is your independent variable. This is what you can intentionally change. And your score is your dependent variable. It's what you measure as a result. So if I go up by every other line being 10 minutes, and for a score, every line is 10. I'm just going to plot my data. Here's our data. And if I draw a smooth curve going through the majority of our points, we've got here a side opening direct square. So how do you linearize this? You're going to square the y values. So we're going to create our linearized graph. I'm actually going to make another column in my data table. Call this score squared. And I'm going to square all my scores. So now we've got our score squared, and we're going to graph our data here. So score squared goes on the y-axis in percent squared. You still have time studying on the x-axis. That's still in minutes. And I'm going to scale my axes. So now I've got my scale, I've got my data points. I'm just going to draw a smooth line to go through the majority of our points. Now we're going to write a model. So I need to know the slope of my line before I can write that model, that equation. So we're going to have a rise of, it goes from 49 up to 6,084. So there's our delta y. Our delta x is 60. So our slope is 100.6. And the unit would be percent squared per minute. So when I write my equation, y equals mx plus b, I've got score squared as y. Slope is 100.6% squared per minute times our x-axis of time, plus our y-intercept, which was 49% squared. In E, we're going to use our equation to determine how many minutes you would study to earn an 83 on your final. So 83 squared equals 100.6 times t plus 49. And if you solve this, you'd get a t of 68 minutes. Now, the numbers for that weren't friendly. They were kind of bigger numbers. For the final exam, we tried to make it a little more friendly with the numbers for you to work with. But you should expect to be able to do something like that by hand. All right. Next page, we're doing a lot of graphing. In this first one, we're going from a position time to a velocity time graph and answering some questions. So for position time graph, the slope represents the velocity. So if we go through segment by segment, the slope for the first chunk, it goes up 4 over 2, so that's a slope of 2, slope of 0. We go down 14 over 2, so that's negative 7, slope of 0. Then we're going to go up 8 over 3, so that's 2.67 as a slope. We're going to use those as our velocities. So I need to scale my velocity graph below here. So I'll just make 0, I'll go 8, 6, 4, 2, 0, -2, -4, -6, -8. First 2 seconds, I need a velocity of 2. Then a velocity of 0 for the next 2 seconds. Then a velocity of -7 until 6 seconds. Then a velocity of 0 again for a second. Then a velocity of 2.67. For question A, displacement from 0 to 4 seconds, I can look at the position graph and just say, all right, at 0 seconds we're at 2 meters, at 4 seconds we're at 6 meters, so my displacement is 4 meters. Or I could have found the area of this rectangle from 0 to 2 seconds of our velocity time graph. 2 by 2 gives you 4. For part B, displacement from 0 to 10 seconds, that's the total displacement. You can look at where we started, 2 meters. We finished at 0 meters at 10 seconds, so that just is a -2 as a displacement. Next problem, we have an AT graph, acceleration time graph, that we need to make from our velocity time graph. Sorry, the numbering on these scales didn't turn out too great, but I think you can make out what they say. We're going from velocity to acceleration, so again the slope from velocity is going to tell us acceleration. So it's 1 segment at a time. Slope from 0 to 3 seconds is slope of 0. From 3 to 4 seconds it goes up 2 over 1, so that's a slope of 2, then a slope of 0, then it goes down 8 over 2, so that's -4. Slope of 0, slope of 0. So I'm going to go to my acceleration graph. I'll put the 0 right in the middle. We'll just go up by 2s, 2, 4, 6, 8, -2, -4, -6, -8. Switch to green. So we have an acceleration of 0 for the first 3 seconds. Then we have a slope of 2, then 0 again, then -4, and then 0 over 10. For the accelerations at these different times, we're just looking for the slopes. So at 3.5 seconds, our slope of our line was 2. So 2 meters per second squared. And at 6 seconds, same thing, our slope was -4. For the displacement from 0 to 10 seconds, we can look at our velocity time graph. We need to find the area between the x-axis and our graph line all the way from 0 to 10 seconds. So I'm going to trace 0 on the graph, and in orange I'm going to shade in the areas we need to find. So I'm going to break this top shape. Actually, let's go with we'll go with a rectangle here. That's going to be 2 by 3, so that's 6. We can go with a tall, skinny rectangle. Tall, skinny rectangle is 1 by 4, so that's 4. Tall triangle is 4 by 1, but divided by 2, so that's 2. Rectangle here is 2 by 1, that's 2. This is 2 by 1 divided by 2, that's 1. Below the x-axis, I've got 1 by -4, and cut that in half, so that's -2. I've got -4 by 1, so that's -4 as an area, and then nothing else past that. So if we add up all of our areas, we've got 6 plus 1 plus 2 plus 4 plus 2 minus 2 minus 4. That should give us 9. And of course you'd have to show that work. I'll end this video here because I'm limited on how long each one can be to post, and I'll pick back up in the next video.